Section 1.9 is composition of functions. So let's take a look at this. Consider this function f of x equals x minus 4 squared. If we were going to evaluate that, first we would plug, First we would plug into the function x minus 4 and evaluate that, and then we would take it and square it. So there are really two functions going on here. So if we call this first function x minus 4, and we call a second function, let's call it h of x, is x squared, then this composite f of x is h of g of x. In other words, we are going to evaluate the h function when we substitute x minus 4 in for x. So this is called a composite function, and it's putting one function inside of another function. So if f and g are functions, then they're composite f of g, and that's how it's read, f of g. This notation, is the same as this notation. F of g of x is the same as f of g of x. This is the notation that I would prefer for each x in the domain of g such that g of x is the domain of f. So x gets put into the g function, and then g of x becomes the input for the f function. G is called the inner function, and its input, that should all be one word, is x. F is the outer function, and its input is g of x. Okay, so let's look at a couple examples here. Here are two functions, f of x and g of x. And we want to do f of g of x. The first thing I'm going to do is change my notation from the way the book writes it to the way that I think makes more sense. In other words, we are taking this f function, and in place of x, we are going to put 2 over x plus 1. So to substitute this into my f function, it's going to be 2 times my whole g of x plus 1 from the f function. So this would be 4 over x plus 2 plus 1. So my final solution is 4 over x plus 3. So f of g of x is 4 over x plus 3. Let's look at this one. This one, I want to take the g function. My input should be f of negative 1. Well, f of negative 1, let me not write that again. F of negative 1 would be 2 times negative 1 plus 1, which would be negative 2 plus 1. So I'm really looking for g of negative 1, which is 2 over negative 1 plus 1, or negative 2 plus 1, which is negative 1. So we've done a little bit of work here with composites, plugging one function into another. The first time with all x values and getting a new function. The second time with evaluating f at a particular value and then using that value for my input to g. So let's look again. Now I've got three functions. H of x is k of f of g of x. Again, let's write this with our inside function and to our outside. So k of f of g of x. So working from the inside out, this is going to be k of f of 2x. F of 2x is plugging 2x into my f function, so now I have the sine of 2x. And k of sine of 2x is plugging sine of 2x into k. So the square root of the sine of 2x is the function k of f of g of x. So just putting one inside the other, one after the other until we have a completed function. Identity and inverse functions. The identity function is y equals x, or we can write it f of x equals x. So if every y and every x are the same, it's an identity function. That identity function happens to look like this. For any one-to-one function, f, the following is true. The inverse function, and this really should have all been one sentence, the inverse function, f inverse of x, and this is a notation. This does not mean, like when we had 3 to the negative 1, it's 1/3. This does not mean reciprocal. When this negative 1 is used within a function notation, it means the inverse function, this is what we call it, is a function so that the composite of f with its inverse, or the composite of the inverse with the original function, will always equal x. So let's take a look at this. So we want to show that these two are inverses of each other by showing that their composite is the identity. So I'm going to start with f of g of x. So that's going to be f of e to the x minus 1 over 3, which is putting this expression into the f function. So ln of 3 times my input value, which now is e to the x minus 1, e to the x minus 1 over 3 plus 1. That becomes ln, those cancel, e to the x minus 1 plus 1. That's ln of e to the x, which is x, so that works. If I do it the other way, it should also work. So I'm going to take g of ln of 3x plus 1. That means all of this is going into this little x value up here. So e to the ln 3x plus 1 minus 1 over 3. This e to the ln of this is just 3x plus 1. Those will cancel and I will get x as well. Since both composites end up being just x, I can say that g of x is the inverse of f. Oops, sorry. Anyway, I can't get that x to write in there. Okay, so let's see what else we can do. Now, if we want to find an inverse, there are a couple of ways to do this. Finding an inverse function means that I want the function that undoes the other function. I know the fact that f of f inverse of x has to equal x. So for this function, I'm going to do the composite. So the outside function is f, the inside function is f inverse. So f of f inverse of x should equal x. So I've substituted my inverse for the x value there. So let's do some multiplication. I'm going to multiply everything here over to the other side. So this is 2 equals x times 3 f inverse of x plus 1. I want to distribute, so now I have 3x f inverse of x plus 3. So I'm going to now, what did I do wrong? Oh, plus x, there we go. Distribute my x. I'm going to subtract the x. So 2 minus x equals 3x f inverse of x, and this is what I want to solve for. So if I divide by 3x, I will get my inverse. Okay? Now, another way to do this, I want to look real quickly. is to change your x and your y. That's what an inverse function means. So if y equals 2 over 3x plus 1, my inverse is going to be x equals 2 over 3y plus 1. Now I can solve for y. That would be x times 3y plus 1 equals 2. 3y plus 1 equals 2 divided by x. Subtracting the 1 and dividing by 3. And if I clean this up by doing a reciprocal, multiplying by the reciprocal, I will get the same value as I do over here. I'm out of room. Let me go over here. So, sorry about that, guys. 2x minus 1 times 1/3. So I've got 2 over 3x minus 1/3. Multiplying this to get a common denominator gives me 2 minus x over 3x, which is what I had here. We'll do another one of these together. I want to show you one more way to find an inverse and talk a little bit more about our inverse functions. But for now, that's going to be it.